Hi class, Mrs. Calvi here with a quick review from 1.2, which was comparing and ordering numbers. Just looking at our number line that we have here. We have 0 in the middle. All of our numbers to the right are positive. All of our numbers to the left are negative, don't forget. Now, remember what we said in class. The larger the negative, the smaller the value. So, the larger the negative, the smaller the value. As I go from right to left, hold on one sec, let me just change my color. If I go from right to left on any number line, my numbers get smaller. So if you look here at positive 5 and I go left, I get smaller to 4, smaller to 3, 2, 1, 0. And then negative numbers, the larger they are, the smaller they get. So the larger the negative, the smaller the value. Now, when I am going from left to right, my numbers get larger, okay? So from left to right, they get larger, all right? Larger. And from right to left, so, hold on. So from right to left, the numbers get smaller. All right, so that's what you have to remember. The larger the negative, the smaller the value. From left to right on the number line, from left to right, they get bigger. From right to left, they get smaller. All right, so keep that in mind. Okay, so take a look at my numbers that I have here. I am comparing 15 degrees Fahrenheit to negative 23 degrees Fahrenheit. So remember, positives are always larger than negatives. So I know here that 15 degrees Fahrenheit is going to be greater than negative 23 degrees Fahrenheit. And if you think about that, positive 15 is going to be somewhere down here on the number line, and negative 23 is going to be somewhere way over here. And as we said, the farther left you go, the smaller the number, all right? So any positive number is always going to be greater than any negative number. Now let's look if we have two negative numbers. So let's say we were comparing negative 18 to negative 7. Think about what I kept saying. The larger the negative, the smaller the value. The larger the negative, the smaller the value. So because negative 18 is larger, that is smaller than negative 7. And you can remember the small little point. Think of that. The larger the negative, the smaller the value. The small little point has to point to the larger negative number. And again, if we were looking at this on the number line, negative 7 would be here, negative 18 would be way over here, okay? And the further left you go, the smaller the value, all right? Now let's say the direction said to graph 4 and negative 2. So remember, graphing on a number line means plotting a point. So we're going to plot a point at positive 4, plot a point at positive 4, and at negative 2. Now, if the direction said to write an inequality to compare these numbers, I would put 4 and I would put negative 2, and an inequality means to use a less than or greater than sign. Well, we know that all positives are greater than all negatives. So 4 has to be greater than negative 2. So if the directions say to graph, you plot the point on the number line, just as I did here. And then if it says to write an inequality, you have to do this. Write the inequality using the numbers that they had given you. Okay, now let's say they told you to graph these integers. So again, you're going to plot the points on the number line. I'm going to plot a positive 1, graph a number 1. I'm going to graph negative 3, plot a point at negative 3, and then plot a point at 5. Now, if it also said to put them in order from least to greatest, you would need to be able to do that. you have to know that all negative numbers are always less than positive numbers. So I know that -3 is going to be the smallest out of these three numbers. The next smallest would be 1, and the largest is going to be 5. So here I had to graph them on the number line, and I had to put them in order from least to greatest. Okay, quick review on some other skills that you're going to see on the assignment. Here it says, what is 10 times as great as 370? So that's the same thing as saying 370 times 10. Well, mental math. 37 times 1 is 37. How many zeros do I have? 1, 2. Add 2 zeros. So what is 10 times as great as 370? Your answer is 3,700. All right? Okay. So this says CJ gave his brother 1/4 of his cars. If CJ has 20 cars, how many did he give his brother? All right, so we have to look at this. He gave 1/4. The denominator in any fraction, that's the bottom part of our fraction, the denominator, tells how many parts in all. So I'm going to draw a picture. Now it says that the denominator is 4. So 4 parts in all. So I'm going to divide this rectangle into 4 parts. Okay? So the denominator tells me how many parts in all. This says 4. I have 4 parts. Now each of these parts of this rectangle, this part, this part, this part, and this part, have to have the same amount inside. They have to be equal parts. Well, it says that he has 20 cars. So how many cars have to go in each of these boxes so that when I add all 4 parts up, it will give me 20? Well, let's think about this. You should be able to figure out that if I put 5 here, 5 here, remember these have to be equal numbers. I can't put a 5 and a 4 and a 3. Whatever number I put in a box, it has to be the same number in every box because these are equal parts. 5, 10, 15, 20. So that makes up my entire 20 cars. Well, if CJ gave his brother 1/4, so 1 out of the 4 parts, CJ gave his brother 5 cars because he only gave him 1 of the 4 parts. So then that means he gave his brother 5 cars. So sometimes drawing a picture really does help you figure out an answer to a problem. Okay, quick review on adding mixed numbers, something that you should have done when you were in elementary school. So if I have 3.5 and I'm adding 2.5, well, when we have a mixed number that has a fraction that is a half, that's pretty easy. We should know what that is as a decimal. 1/2 is equivalent to, so 1/2 is equivalent to 0.5 as a decimal, right? So if you think of money, you would think of like maybe that's 50 cents, all right? So if I make this, instead of it being a mixed number and I make it into a decimal, that would equal 3.5. And then if I add this one, 2.5 would be 2.5. So now if I add my decimals, whenever we add decimals, we have to line up our decimals. So I'm going to take 3.5, I'm going to add 2.5, and I'm going to add 5 plus 5 is 10. Don't forget to carry down your decimal. 1 plus 3 is 4. 4 plus 2 is 6. So 3.5 plus 2.5 is equal to 6. Now let's say we didn't want to change them into decimals and we wanted to keep them as fractions. So I can look at this as, these are easy fractions, halves. You should know that 2 halves make a whole. So I know that this 1/2 and this 1/2, when you add them together, will equal 1 whole. So I can add 1 whole to my whole numbers here. Then I would take the 1 plus 3 plus 2 to get me a total of 6 for my answer. So that's another way you could do it. A third way you can do this is change the mixed numbers into improper fractions. So when you did this in elementary school, changing mixed numbers into improper fractions, I'm going to take my denominator, multiply it by the whole number, add in my numerator. So 2 times 2 plus 1. So let's go ahead and do that. So 2 times 2 and then add the 1. I'm going to do the same thing with my top mixed number. 2 times 3 and then add the 1. Then my denominators stay the same. So let's first work with the 1 on top. 2 times 3 is 6. 6 plus 1 is 7. And then my denominator of 2 never changes. That will stay. So now let's do this one. 2 times 2 is 4, plus 1 is 5. Denominator stays the same. Now, when our denominators are the same, I just take my numerators, add them together, and keep my denominator. So I'm going to add these. 7 plus 2 gives me, 7 plus 5, 7 plus 5 gives me 12, and the 2 stays. Well, now I have an improper fraction. An improper fraction is when my numerator, my top number, is bigger than my bottom number. But this fraction bar means to divide. So what is 12 divided by 2? 12 divided by 2 equals 6. So if you notice, we got the answer 6 3 different ways, all right? So we changed it into improper fractions, we changed them into decimals, or we just knew that 2 halves equal a whole, and we could add that to the whole column, all right? I will talk to you guys soon.